I'm Steve Holden. I've been using Python for a while. I've been programming a long time as well. I started in 1967, so I celebrated 50 years as a programmer recently. Completely insane by now, of course. But so I learned programming as a computational scientist. I've been involved with writing about Python. Do we have any Python users in the room? Oh, that's not bad for a C++ conference, is it? Nico's talk, amazing amount of detail in that talk. And it took me back a long time to the early days of Python. Not quite this far back. This is the, the Manchester Mark I, which was constructed by a Yorkshireman, Tom Kilburn, 2 years before I was born. So programming was hard. You've just built the first computer in the world. So there is no operating system, there are no libraries. Ultimately, you have to flip bit switches to set things in memory to run the initial programs. And of course, what's been going on ever since then is that we've been inventing layers of abstraction and building on them. And that process has gone on and on and on. So after about 30 years, we come across the VAX 11780, a very popular machine of its time. This is actually the benchmark 1 MIPS machine. This is what this was 1 million instructions per second in computer power. That was taken as the benchmark that everything else was measured against. Of course, by that time we'd got things like assemblers and compilers, so it was much easier to use the computing systems. Unix was starting to emerge as a fairly common software base. You could rely on the operating system having disks and a file system, and we were starting to play with this idea that, well, as Sun Microsystems used to say, the network is the computer, so distributed computing could take off as soon as ubiquitous wide area networking was available, and of course now, businesses take that for granted. So in 1984, that's one of the early Macintosh machines. That was just a bit less than a MIPS, I think. In 2015, I came across this little device. It's a chip, system on chip, about 1.5 inches by 1 inch or 2 by 1 centimeter, as if you're more modern than I am. And it's got Wi-Fi and Bluetooth built in. This is the D1 Mini. It's a machine that by default is micro-programmed to run Lua, but you can also run Python on it. But the idea is, I mean, now, I've got chips available which have 5 different types of networking built in: Sigfox, LoRa, Bluetooth, Wi-Fi, and so on. And the machine on the right is the latest version of the ESP machine, which has 200 MIPS of computing power. So there's a lot been going on in the past 50 or 60 or 70 years in computing, and whatever comes next is bound to be increasingly complex. And so that's when I went back to my early days. I was watching Nico's talk, and that reminded me of, shall we say, days when relationships between different languages were conducted in a less polite manner. And so, wanting to dismiss Python as many people seem to, they tried to put it down as a scripting language, which was, you could always get a rise out of such people by asking them what a formal definition of a scripting language was, and nobody could ever come up with them. And of course, in turn, younger Python programmers would start to talk about C++ as the bondage language and this kind of stuff. But the problem with taking offense, as Seth Godin says, is once you've taken it, you're basically left with it. Now, Python isn't actually one of those languages that's in your face. You don't have to use Python, and indeed, the whole history of Python is one of playing well with others. So we've been able to have extensions in C, and thanks to extensions like Swig and Boost, we've adapted to C++ as well. There's a quote which is frequently attributed to Mahatma Gandhi, which isn't actually a correct attribution, but anyway, you've probably all heard, first they ignore you, then they abuse you, then they crack down on you, and then you win. Well, it's not really a matter of winning, but basically the quote I prefer is the actual Gandhi quote: "Ridicule is like repression. Both give place to respect when they fail to produce the intended effect." So effectively, Python's just been kind of going its own merry way. And a lot of people object to Python because well, it doesn't have static typing, so you can't optimize it. But as a learning language, that's ideal. And one of the things, the principal differences between Python and other programming environments is you simply don't have to think about the details that were discussed in the Kotlin keynote this morning, or the details of C++ that Nico was talking about. And mostly, what a beginner needs is a simple, consistent environment. Execution speed hardly matters for beginners. And if you give them a language that will directly allow them hands-on experience, which we can now do right down to the chip level, you can write interrupt handlers in Python now, you don't need large resources. What you need is a widely available system that's easy to access. So when I think about Python, I don't think about the specific set of professional software engineers as the principal audience. The important thing about Python is it makes programming readily available to people like scientists, lab technicians, teachers, not just of mathematical subjects, but other subjects as well. Self-guided learners can pick it up, and they don't have to worry about the details of memory allocation and so on. Obviously, that's all got to take place under the hood. And when people complain about what they see as Python's sometimes slow execution speeds, what they're not taking credit for is the huge amount of detail that slower execution speed is subsuming. It's doing all the complexity of memory allocation, deallocation, all that kind of stuff. So why do people use Python? First of all, I think it's an easy language to learn. I recently, I thought, well, I'm coming to a C++ conference, I'd better brush up on my C++. And we do actually use C++ at work, by the way. We've got a common computation layer to which we've now got an Objective-C shim to our Swift code in iOS. We're building a Gradle-based interface to the same code for Java users writing an Android application, and we've also got a Python interface to the same routines. So that means that C++ is actually providing our underlying computational primitives. So it's not like I'm saying there is no place for languages like C++. But you have to admit that when you're a beginner, it's much nicer when you've got a simple object model, a consistent object model. So one of the problems I always found with Java was that they immediately made this horrendous sacrifice to optimization by differentiating between boxed and unboxed values. So an unboxed value had no object overhead, and it was more efficient and fine. But what does that cost the programmer to have to learn? The new Java programmer has to learn, well, there's ints and there's integers, and they have these different properties, and you can do some things with one and some things with the other. The other thing is that unlike most assignment models and most memory models, in Python, names are simply references to objects. So you find names in namespaces, which are created when a function is called or when a new instance of some class is created. But all data, all objects, live on the heap, and this has certain advantages too. So Python's got very simple assignment semantics. Basically, as long as there is a live reference to an object, it will be retained on the heap. And so there's no such thing as a dangling reference. If you create an object in a function in Python and return it, and that return value is bound to a name, then the value continues to exist. No problem, because we're not allocating functions on the stack. Sorry, we're not allocating data objects on the stack. We're simply creating references to data objects in the heap on the stack. And as a result of this different namespace, effectively, a name is simply a reference to a value. And an assignment statement in Python never copies data. It simply copies a reference to the object. And another reason people like to use Python is because of its ability to, it's got the read, evaluate, print loop. So you can open up the Python interpreter, you can type statements in, you can see the results, and of course that means that, again, you've got more power than the user of a language who has to go through a compile stage in order to get something executable to see what happens if I do this. So again, Python encourages people almost to poke about with it and to look under the hood. And of course, Python's got great features for introspection as well. So people talk about Python as though it's a single language, but in fact, there's an ecosystem. And more recently, we've seen with the introduction of what originally started out as the IPython notebook, and then became the Jupyter notebook, and has now become the Jupyter Lab, that we can actually integrate Python, and I should add other languages too, into a wonderful computing environment where you can mix executable code, comment in Markdown. If you need the mathematics for a particular function to be described above it, you can include that. And this is a terrific way for people whose primary interest is solving problems rather than writing software, because don't forget, the majority of the programming audience hate programming. They don't want to program. It's just that programming is the only way to solve their problem. So let's give us easy ways to communicate their solutions. So here's an example of a Jupyter Lab session where we can see the files that the user's got available in the directory on the left-hand side, and we've got a graphic and some Python code above it, and Markdown and graphs and so on. And here's another one with rather more graphs where a data analysis is being done. So the Jupyter environment basically pulls you into Python and makes it immediately available. There's an implementation called Pipy, or PYPY, depending on how you pronounce it. And that was originally an EU-funded experiment to write an implementation of Python in Python itself. And so they took a subset of Python called RPython, which was restricted enough to be compilable. It elided a lot of the dynamic features of Python. And they've been able to develop a system that with just-in-time optimization allows you to obtain C-like speeds on regular Python code, retaining the clarity of Python. There's an implementation called Sizin, which is an optimizing static compiler. It allows you to embed C typing into your Python and to interface C and C++ code relatively easily. There's an implementation called MicroPython, which is what you can use to write interrupt handlers on the later pieces of hardware that I was showing you there. There's even an interactive system available called pythontutor.com that allows you to step through the execution of your code, and it shows you the functional namespaces, the objects in them, and so on and so forth. So when people ask me why I've been stuck with or stuck on the Python language for over 20 years, I suppose the answer is that Python originally attracted me because of its freedom and its great sense of fun, the ability to create complex objects interactively by importing a module and creating instances, the ability to hook my own classes into the standard language system so I can write methods which automatically correspond to specific operators. And while Python I would never claim is a good language for writing domain-specific languages, that's actually one of the more interesting aspects I discovered about Kotlin this morning. But nevertheless, you can very flexibly hook your own classes in there, and it's easy for the motivated student to learn. It pulls them in. So you can do all kinds of things in Python. People are genuinely using all these applications and more. Science instrumentation, scientific data collection is now huge in Python. You probably heard that the recent gravitational wave detection and the LiGAR equipment was principally, not entirely, but principally handled by Python data science code. So, as far as I'm concerned, the reason that Python is a fabulous language is because I don't want computers to be the exclusive domain of the privileged who know mathematics and computer science. And I'm adamant that we should teach people computer programming first, because most people don't need computer science. And a lot of people who are using the term computer science don't really know even what computer science is. So Python actually gives you direct hands-on experience, puts you in control, and lets you find your own uses for computers. Thank you very much. Do we have time for a question or not? Good. Hello.
I just wanted to make a comment that there's a team of people who probably within the next 2 or 3 months will be shipping interactive C++ support in Jupyter Lab.
An interactive C++ environment in Jupyter Lab. Well, I'm delighted to hear it. Excellent. In the next couple of months?
Yes.
By winter, definitely, right?
By winter.
Yeah. We won't say which winter. No, there's all kinds. I mean, the R languages in there. I think there's about 35 different language kernels now for the Jupyter environment. Come on in. The water's lovely. Hello.
As more and more people have to become programmers who have nothing to do with computer science, people in labs, people in
We might call them the reluctant programmers, yeah?
not necessarily reluctant, but they're the kind of naive programmers who wander in.
Yep.
Do you think that Python, I think there are going to be more of those people. Do you think that Python itself is going to also see more professional programmers coming in through that route than ever before, more than other languages?
So is Python going to see what? Is it going to attract professional? When you say professional programmers, you mean what? People who have to program to get their profession?
Sorry, I muddled up all my words. What I meant was,
Use your words, Daniele.
do you think that Python is going to see an influx of new programmers?
Yes.
Some of whom are these programmers who have to be programmers.
Yeah.
But some of them will become part of this body of advanced professionals who develop an advanced language.
Absolutely, yes. Well, I suppose the way I would respond to your question is Python going to see professional software engineers coming in as well as the people who have to program because they need it to get a job done? Yeah, I think Python is attracting such people, yes. Because as it builds larger and larger systems, people are beginning to understand that hey, the Python helps me solve my problems. But at the same time, as you're probably aware, that type annotations, for example, give us the possibility, if you like, almost to turn Python into a bondage language. You can introduce type annotations, which are syntactically permissible, but in the standard Python implementation do nothing. But you can then analyze that same code with third-party tools to be able to determine, well, okay, this function reliably receives integers as its arguments and it returns an integer, so therefore we don't even need to use the Python object model. We can simply write a function that uses the integer representations by the hardware without the user themselves becoming available. So I think the answer is really, in self-defense, people have to use languages like Python because otherwise there's simply too much thinking to do to organize the increasingly complex systems that we're now having to build. Yes?
Yeah. Many thanks for the talk.
Pleasure.
Kind of interesting. Just a comment. One of the kind of areas that I think Python is really well now as things stand is the AI. Because there's some lovely machine learning libraries that people get into very, very quickly indeed.
Yes, Python is indeed. As one of my other hats is a member of the organizing committee of PyData London, which is, I recently learned, the largest data science meetup in the world now. We've got about 7,000, 7,500 members. And a lot of those people are interested in AI. But I sometimes do wonder how much bad code we're going to see written by people who simply put such algorithms to use without really having too much understanding of the underlying abstractions. Whether that's a good thing or a bad thing, I don't know. It's probably above my pay grade to say. Okay, looks like we're done. Thanks very much, everyone.